Okay, so today we are going to look at logarithms again, and basically we're going to look at how we can take them apart and put them back together. And we're going to call that expanding and condensing logarithms. And in order to understand how we can expand and condense logarithms, we kind of think about back to exponents. These are exponential, they have the exponents in there with the variable and the exponent. And we think about our rules that we had for exponents. And if you think back, when we had exponents were being multiplied together, what did we do? Well, we said x to the fourth times x to the third. We would add 4 plus 3, and we would get x to the seventh. We added our exponents. These two things are multiplied together, which translated into addition. When we had, when they're being, that should say divided, not added, my bad. When exponents are being divided, okay, like this, x to the 8th divided by x to the 5th, we would say 8 minus 5, and we would get x to the 3rd. And it would be x to the 3rd in the numerator because that 8 is larger than the 3. And then when we had power of a power, we would take that 2 and multiply it by 5, and we would get 10. Okay, this one's not quite as similar to what we're going to do with logarithms, but it is still something to think about because we're going to multiply there. Okay, so our properties of logarithms, just like we know our properties of exponents, is just, again, the product property. Product means multiplication, and if you look, you have log base b of m times n. That right there is multiplication. Okay, and if you think back to our exponent rules, when we multiplied, when we simplified that meant we used addition to simplify. Okay, we're going to do the same thing when we're expanding. So if we had log base whatever, base b of m times n, where you're multiplying to break it apart or to expand it, okay, we're going to call that when we expand it, we are going to expand it with addition. And like on this one, when we have division, m divided by n, okay, that means we are going to expand it using subtraction. And the power property, it is being raised to a power. That means we're going to multiply. So basically what we're going to do is we're going to move that exponent out in front, and we are going to multiply that exponent times our log. Okay, so let's go ahead and look at how that looks with some examples of problems with actual numbers and variables rather than what we have here. Okay, so we have log base 4 of 2x. These two things are being multiplied together, and it wants us to expand that. It means we want to break it apart into more pieces. To do that, remember, multiplication means that we use addition to break it apart. So we're going to have log, don't forget your base, 4 of 2 plus log base 4 of x. We just took that first factor there in the 2x, the 2, and that's our first here. And then we have log base 4 of x, so we just took that 2x, broke it apart with addition. Okay, same thing here with log base 5 of 3y. I'm going to have log base 5, that doesn't change, that's still the same thing, log base 5 of 3 plus, because those two things are multiplied together, okay, log base 5 of 3 plus log base 5 of y. And when we expand them out, we're just taking a nice condensed, nice simple piece of math there that's all put together and making it bigger and expanding it out. On these next two, we have division. Those didn't copy exactly very well. That should have a fraction bar in between there. Okay, so we have division, 3 divided by 7. Okay, so this is division, which means if we have division, we are going to use subtraction to separate them out and or expand them out. So I'm going to have log base 2, my top number is 3, and division means I'm going to subtract log base 2 of 7. And that's as much as we're going to do for right now. Okay, so then the next one, we got log base 5 of 5 divided by 8. Division means subtraction. So we're going to log base 5 of 5, okay, minus log base 5 of 8. And technically, if we wanted to, log base 5 of 5 is a number, log base 5 of 8 is a decimal number. We could put them in numbers, but we are going to leave them in terms of logs. Okay, these last two are that last property, the product, or excuse me, not the product property, the power property, where we have this exponent right here on both of them. Okay, and remember when we have a power in there, that means we're going to use multiplication. So we're just going to take that 2 and multiply it out in front. 2 times log base 3 of 5. Okay, all we did, we're just going to multiply 2 out in front. Take this 3, multiply it out in front. 3 times log base 6 of 7. Okay, and just keep in mind, we used, all these examples were with logs. You can also use natural log. So if any of these happen to have been a natural log, you could have done the exact same thing. Okay, so for instance, if we would have had like natural log of 7x, okay, that would be the natural log of 7 plus the natural log of x. So natural log works with the same rules as logarithms. Okay, so on that last slide, we took them apart, okay? Now we're going to put them back together, okay? So now they're already broken apart into separate pieces. Now we're going to look at what operation each one has there. And we're going to say, well, what does that mean if we want to put it back together? So I have log base 2 of 3 plus log base 2 of 8. Okay, remember that addition means that we are going to multiply. Now we're going the other way. Since it's addition here, that means we're going to multiply 3 and 8. So I would have log base 2 of 3 times 8, which is just log base 2 of 24. Okay, so that addition told me that we needed to multiply to put it back together. Okay, looking at our next one here, this one's got a little bit more going on because we have two things here. We have that 2 out in front, which is multiplication, and we also have subtraction. Okay, so our first term here, this log base 5 of 4, doesn't have anything we really need to do to it yet. We need to look at this second term for just a quick minute here. So before we think division, okay, we're kind of doing the order of operations here. Before we think division with this subtraction sign here, we need to think about this exponent that's going to be put back in its place when we put it back together. So we would have log base 5 of 4 minus, we're still keeping that minus there, log base 5 of 5 squared. We just took that 2 and put it back into its place as its exponent. So then we have log base 5 of 4 minus log base 5 of, well, we know what 5 squared is. That's 25. Now we can deal with this subtraction sign and say log base 5 of 4 over 25. Okay, so we're just working our way backwards from what we just did. Instead of putting, taking it all apart, now we are putting it all back together. Okay, so let's go ahead and look on here at the next one. Again, we got several things going on here, okay? We always want to think in terms of exponents first, because order of operations thinks exponents. Well, this 3 out in front here means that it needs to take its place back up as an exponent first. So we can say that, and again, just because it's a natural log doesn't mean we treat it any differently than a log. But we're going to have the natural log. And notice this 3 is being multiplied by the natural log of 6x. It's not just being multiplied by 6, and it's not just being multiplied by x. It's being multiplied by both of them. So we're going to have the natural log of 6x, and we need to put that in parentheses to the third power. Okay, so that I know when I'm taking this third power back up here, I'm applying it to both the 6 and the x. And then I have the natural log plus the natural log of 4y. Then we just have to do a little bit of simplifying. Okay, the natural log, 6 to the third power is 216. X to the third power is x to the third plus the natural log of 4y. Now we have everything in its place. We can multiply them together because of our addition here. We can, since we have addition here, we can go ahead and multiply these two things together. So we're going to have the natural log, 216 times 4 is 864. Excuse me, 864. X to the third is still x to the third. We're just multiplying those three things together. So we're multiplying our coefficients here to get 864, and then we are multiplying x is just going to be our x, and y is a y when we multiply it out. So we're going to end up at the natural log of 864 x to the third y. And again, now instead of having it all expanded out, we have it on one term. One more on here? Nope, two more. Okay, so let's take a look at this next one. Oh, I got to go over here to look at the next one, number 12 over here. This one is pretty simple. There's nothing out in front being multiplied. Out here in front, there's nothing being multiplied here, so we don't need to worry about moving anything into the exponent. We just have log of x minus log of 9. That subtraction tells me I need to divide, so I'm going to have the log. And again, we don't have a base, so we don't have to write anything there. Subtraction means I'm dividing x over 9. That one was much easier than our last one. Now let's look over here on our last question here. Hopefully you notice, right, there isn't anything out in front that we have to worry about here in front of that natural log. However, we have a 3 out in front of this natural log, which means that 3 needs to be dealt with first to become its exponent. So this natural log of 4 doesn't change. That's going to stay the same, plus the natural log of 3. We need to move that 3 back up into its place as the exponent. So then we have the natural log of 4 plus the 3 to the third is 27, the natural log of 27. Now this addition here tells me that I need to multiply these two things together. So I'm going to have the natural log, and 27 times 4 is 108. Okay, so those are just some examples of this is how we condense when they're all taken apart. That previous slide is how we expand them out. What I would like for you to do is the next 2 slides. So this slide right here, you're going to expand, so you're going to break it apart using addition and subtraction and multiplication. And then the last slide, this last slide, you are going to put them back together. So we're just doing some extra examples here of what we just did in our lesson video. So I want you to go ahead and do these last 2 slides on your own for homework,